All right, let's talk about something fascinating. We're diving into the story of a chemical that, get this, started out as a simple blue dye for clothes. But over the last 150 years, it's become this medical jack of all trades, just packed with surprises and honestly, a lot of contradictions. So, yeah, let's unravel this thing. So, here's the puzzle at the heart of it all. On one side, you've got methylene blue being talked about as this potential metabolic enhancer for the brain, something that could rev up our cellular engines, maybe even help with diseases like Alzheimer's. But then, bam, a huge study in 2023 comes out and finds it does the exact opposite. It actually seems to reduce blood flow and energy use in the brain. What's up with that? Right? So that's the big question we're chasing today. How can a supposed brain booster actually be hitting the brakes on its own fuel supply? It doesn't add up. It feels like a total contradiction. To get to the bottom of this little medical detective story, we've got to go back, way back. Okay, so to figure this out, we need to dig into its secret history. We're going from textiles all the way to toxins. I mean, the resume of methylene blue is just wild. It kicks off in 1876. Created as a dye for stuff like blue jeans, simple enough. But just 15 years later, the legendary Paul Ehrlich figures out he can use it to stain cells, which basically helps kickstart model chemotherapy. Then boom, it's one of the first real treatments for malaria. And if that's not enough, by the 1920s, it's a life-saving antidote for cyanide poisoning. I mean, think about that jump, from coloring clothes to saving lives in under 50 years. Incredible. And here's a crazy little side note from its malaria-fighting days. The drug was so potent, patients had two side effects you just couldn't avoid. It would turn their urine green and the whites of their eyes blue. Yeah, no kidding. A pretty vivid way to know the medicine was working, right? Okay, so let's jump to the present day. You'd think a 150-year-old drug would be a relic, right? Something in a museum. Nope. Methylene blue is basically medicine's comeback kid. It's having a total modern renaissance. And today, it's a serious high-tech tool. In the ICU, it's used to treat this really dangerous type of low blood pressure. But where it really shines, literally, is in surgery. See, if you put it under near-infrared light, methylene blue glows. It fluoresces. And this is a game changer for surgeons. Suddenly, they can see things with incredible clarity. They can protect delicate structures, spot tiny abnormal glands, and even see the exact edges of a tumor while they're operating. Just amazing. So we've got this dye that's also a lifesaver and a surgical guide. But how on earth did it get a reputation as a brain booster? Let's get into the theory of how it's supposed to work. Okay, so the whole idea comes down to our mitochondria. Just think of them as the tiny power plants inside every single one of your cells. And the theory goes that methylene blue acts like a super skilled engineer. When the main power production line gets jammed up, it steps in and creates this clever little workaround to keep the lights on. So here's how that's supposed to happen, step by step. First, it zips right across the blood-brain barrier and makes a beeline for those mitochondria. Then, once it's inside, it acts like an electrical bypass. If the normal flow of energy gets blocked for some reason, methylene blue can jump in, grab the electrons, and keep the whole assembly line moving. The end result? Your cell uses more oxygen and pumps out more ATP, which is the actual energy currency for your body. It's the very definition of a metabolic boost. Now, that theory sounds great, right? It makes perfect sense. But it totally flies in the face of that 2023 study. So what gives? It's time to solve this puzzle, because it really all comes down to one simple, powerful idea. The dose makes the poison. But like we said, in 2023, this really groundbreaking study came along and found the exact opposite of what everyone expected. All that theory pointed one way, but the real-world human data pointed the other. Just look at the data they found. At a dose of 0.5 milligrams per kilogram, brain blood flow went down by over 8%. Oxygen use went down by almost 8%. And when they bumped the dose up a little bit to 1 milligram per kilogram, that drop in metabolism got even bigger, almost 12%. The numbers don't lie. At these doses, it wasn't a metabolic enhancer, it was a metabolic reducer. So what in the world is going on? Well, the key to this whole mystery is a really cool biological idea called the hormetic effect, or hormesis. And here's the core concept. For some substances, the dose doesn't just determine how strong the effect is, it can actually flip the effect on its head completely. Here's the perfect analogy. Exercise. A little bit of it, like a good workout, makes you stronger. That's a positive effect. But way too much, like running a marathon without training, can cause serious injury. That's a negative effect. Same thing, different dose, opposite result. And it looks like methylene blue works in exactly the same way. Finding that just right Goldilocks amount, well, that's the whole puzzle scientists are working on now. And this right here, this explains everything. It looks like at very low doses, lower than what they used in that 2023 study, you get the benefit. You get that metabolic enhancement. But then you hit the middle range, the kinds of doses used in hospitals for other treatments, and the effect flips. It becomes a metabolic reducer. And then, if you go to really high doses, it's just plain toxic. So you see, the 2023 study wasn't wrong at all. They were just operating in that middle inhibitory zone of this curve. So, after all that, we're left with this one big thought. Here we have this 150-year-old medical marvel that went from dyeing pants to saving lives. And its next chapter, its future as a tool for brain health, might not hinge on some brand new discovery, but on something way more subtle. It's all about finding that perfect, tiny dose. The biggest challenge isn't figuring out if it works, but how much to use. And that is a puzzle worth solving.